say that I have like 4x plus 1 over 1 plus x squared dx. Now look at this problem. In this, direct substitution is not working. If I say that 1 plus x squared equals u, I don't get everything from the top. So then we need to do a little trick in here, like you can distribute 4x over 1 plus x squared plus 1 over 1 plus x squared. Does it make sense? I can separate. I have two terms here, one here, another here, and then I can split like that. When I do that, now you can see this one now works with the substitution, because if I say 1 plus x squared is u, then x dx will come out. Okay, you can put parentheses or without will be fine. So then for this part, I say 1 plus x squared equals u. So then 2x dx will be my du. By this time, I think you are expert. Now you know what I'm doing. So I'm taking 1 plus x squared is u. So then 2x dx is du. This 4 you can pull outside. Just use two forms. X 1 plus x squared dx plus 1 over 1 plus x squared dx. Now if you look at here, x dx, this one I have here, x dx, which is 1/2 du. 4 times 1/2, and you get du 1 over u du. Derivative of tan inverse x is 1 over 1 plus x squared. So then the integral will be tan inverse, other way. So then you can just say tan inverse, or you can say arc tangent. And what happens here? This is 2. 1 over u will give you now natural log of u plus tan inverse x plus integral constant. Now this u you need to substitute back with what we have taken, 1 plus x squared. Question number 8. I'm taking now, say, integral sine x 1 plus cosine squared x dx. Okay, this is very nice problem. And you see, if I say cosine x is my u, not the square, okay, just u. So then in the denominator I get 1 plus u squared. Do you see that? So 1 plus u squared is actually this type of integral. So the substitution rules are taking your complicated shape of the integrals to very basic shape that we have seen in Calc 1. So if you say u equals cosine x, then du will be negative sine x dx, and that helps me here, see that? Sine x dx. So then I'm getting negative 1 over 1 plus u squared du. Do you see that? And when I have converted this one to 1 plus u squared in the denominator, we know that this is the function tan inverse u. So then when you substitute your u by cosine x, it will look like negative tan inverse cosine x plus constant, and we are done. Thank you. We'll go to the next example now. So this problem is like this. Arc sine x to the 3 divided by square root of 1 minus x squared dx. Okay, we'll say this. So then you can see arc sine is related to 1 over square root of 1 minus x squared. Remember from the derivative rules? So then we say u equals arc sine, and remember arc sine is same as sine inverse These are two different representations. So then du will be, we know derivative of sine inverse is 1 over square root of 1 minus x squared dx. Okay, so then you can easily see 1 over square root of this dx is just du. So my problem is reduced to u to the 3. See that? So beautiful. Now what is the integral of u to the 3? We know is power rule, u to the 4 over 4 plus a constant. And then substitute back what is u. This one will be 1/4 arc sine, you can write, or sine inverse to the 4 plus a constant. And we are done for this problem. Derivative of 1 over x is negative 1 over x squared. Can you confirm me why? Because I am going from this, see, derivative of 1 over x meaning is x to the negative 1, yeah, and then derivative is negative 1 x to the negative 1 minus 1. That gives me negative x to the negative 2 and then negative 1 over x squared. Yeah, so if you do this is faster, you will enjoy the rest, and just pay attention on this one, you can easily see it. So then derivative of 1 over x is negative 1 over x squared, and you will see why I'm taking this example. I'm going to one integral problem. So the problem is like this. We are given integration number 11, I think. Integration cosine 1 over x divided by x squared dx. This is the shape now, look. So then what is your u? Must be 1 over x, because I need cosine x type or cosine u type. So that's why 1 over x is my u. When I take the derivative, I get du is negative 1 over x squared dx. Now the factor here, you see that x squared 1 over x squared dx is already here. So 1 over x squared dx. So then I'm getting negative in front, integral cosine u du. And we know that the integral of cosine is just sine, and the negative is already there. So then you have sine u plus a constant, and then substitute back what is u. Negative sine 1 over x plus c, like that. Yeah. So for example, if I change this problem slightly, say that I'm writing here 11, how my problem will change? Say that I'm writing just 11 instead of 1. So how this problem will change? Not much. Not much. I will just say that my u equals 11 over x. That I will say. And then my du will be negative 11 over x squared. The constant will be preserved, dx. And this constant, then I will move on the other side, it will come out as 1 over 11 negative, and then I cancel this one. So then that side will be just 1 over x squared dx. So then this problem, when you solve, additionally this constant term will go in front. Is that right? Yeah, so the basic shape is still same.